Hello students, hello and welcome to this video. In this video, we will solve question number 121 to 130 of determinants. The link to download the PDF will be in description, as well as at the end I will show you how you can download and maintain an updated copy of the PDF. I will also show you my question answer website where you can come and ask or answer questions. So without further ado, let's get started. Question 121 asks us to evaluate the determinant b plus c whole square, a square bc, c plus a whole square, b square ca, a plus b whole square, c square ab. It's a pretty easy question. We perform c1 minus 2c3. So 2bc, 2ca and 2ab are removed from first three. So we have b square plus c square plus a square plus b square. Now you can see that we need to perform column 1 is equal to column 1 plus column 2. We don't need column 3. Okay, this is again a mistake. So if you do column 1 plus column 2, you will get in the first column a square plus b square plus c square, which we can take out. So we will be left with 1, 1, 1, a square, b square, c square, bc, ca, ab. So we know that this is equal to a minus c, b minus c, c minus a, abc, a plus b plus c. So the full determinant is a square plus b square plus c square times a plus b plus c times a minus b times b minus c times c minus a. Question 122 asks us to prove that x square, y square, z square in the first column, x square minus y minus z whole square, y square minus z minus x whole square, z square minus x minus y whole square in the second column, yz, zx, xy in the third column is equal to x minus y times y minus z times z minus x times x plus y plus z times x square plus y square plus z square. So we perform C2 is equal to C2 minus C1. So if we do C2 minus C1, this x square, y square, z square will be gone, and we take minus common. Then we perform column 1 is equal to column 2 plus column 2 plus column 3, 2 times column 3. So if you do that, the first column will become x square plus y square plus z square, and all the elements will become x square plus y square plus z square. And then we take out x square plus y square plus z square, and then we will have 3 ones. We perform R3 minus R3 is equal to R3 minus R2, R2 is equal to R2 minus R1. We get 2 zeros in the first column. Upon expansion, you will get the result. So this is quite similar to this determinant 121, and we have the similar answer. I mean, I think it has the exact answer. Okay, so you can proceed like 121 and you will have the answer. So 123 says that if A1, B1, C1, A2, B2, C2, A3, B3, C3 are three-digit numbers such that each of them is divisible by k, then prove that the determinant A1, B1, C1, A2, B2, C2, A3, B3, C3 is divisible by k. So very easy question. So we know that A1, B1, C1 is equal to 100 times A1 plus 10 times B1 plus C1 is equal to Pk, where P is in the set of integers. A2, B2, C2 is 100 times A2 plus 10 times B2 plus C2 is equal to Qk. Similarly, Q will be in the set of integers. A3, B3, C3 is equal to 100 times A3 plus 10 times B3 plus C3 is equal to Rk, where R is in the set of integers. So what we do is we do column 3 is equal to 100 times C1 plus 10 times C2 plus column 3. So in the column 3, we will have Pk, Qk, Rk, and we take k out, and it makes the determinant divisible by k. Now question 124, it says that if there is ai, bi, ci in the set of real numbers, where I is in this, I is equal to 1 to 3, and x is also in the set of real numbers, then we have to show that a1 plus b1x, a1x plus b1, c1. And similarly, we have a2 plus b2x, a2x plus b2, c2, and similarly we have O3. This is equal to 1 minus x square, a1, b1, c1, a2, b2, c2, and a3, b3, c3. So we solve this. So what we do is we split the first column. So if we split the first column between A1 and B1x and so on, we will get A1, A2, A3 in the first column over here, and then B1x, B2x, and B3x in the second column here. Now we can take out x from this and we will have B1, B2, B3. Once we have that, what we can do is we can split this second column into two. So if you split this and take x common from A1x, A2x, A3x, you will have A1, A2, A3. That is, first column and second column will become equal. And this second half will be A1, B1, C1, A2, B2, C3, A3, B3, C3. That is this one. And then if you split this, then you will be left with B1, B2, B3, A1x, A2x, A3x. So you need to take x common again and you will have that. And then this will become B1, B2, B3, B1, B2, B3, two columns same. So this will be also 0. So now we have this determinant and we have this determinant. And then you exchange the column 1 and column 2 here. You will get 1 minus x square and times that. Okay. So that's how you will have the determinant. So here you see this third determinant. We need to change the columns A1, A2, A3 and B1, B2, B3 so that we can take the determinant common and we will be left with 1 minus x square. Question 125 says that if a, b, c are roots of the equation px cubed plus qx square plus rx plus s, then find the value of 1 plus a, 1, 1, 1, 1 plus b, 1, 1, 1, 1 plus c. So what we do is we divide the first row by a, second row by b, and third row by c. So we need to multiply by abc. And our determinants become this 1 upon a plus 1, 1 upon a, 1 upon a, and so on. Now, once we have that, we can perform column 1 is row 1 is equal to row 1 plus row 2 plus row 3. So the top row will become all cells will become 1 plus 1 upon a plus 1 over b plus 1 over c, and we take that common. So we'll have 3 ones here, and then you know what to do. C2 is equal to C2 minus C1, and C3 is equal to C3 minus C1. So we'll have two zeros, and then you expand, you will get this. Okay, this will be 1 only. Now we have delta is equal to this, and we are given that ABC are roots of qx cubed, qx square plus rx plus s. So we can write that qx cubed plus qx square plus rx plus s is equal to x minus a times x minus b times x minus c. So from Vieta's relationship, we have that a plus b plus c is equal to minus q upon p. AB plus BC plus CA is equal to R upon P, and ABC is equal to minus S upon P. So once you see that if you multiply this with the factor inside the parenthesis, we will get AB plus BC plus CA from the first three and then ABC. So this is equal to R upon P minus S upon P. So taking LCM, we get R minus S upon P. Question 126 says that if A less than B less than C, prove that 1A raised to the power 4, 1B raised to the power 4, 1C raised to the power 4 is greater than 0. So we have this 3 ones. So we perform R2 is equal to R2 minus R1, R3 is equal to R3 minus R1. Again, this should be underscore. I have lots of underscore typed as minus. So we will have this determinant here. We take B minus A out, and not B minus A out, we simply evaluate the determinant. So we'll be left with B minus A times C to the power 4 minus A raised to the power 4 minus C minus A times B raised to the power 4 minus A raised to the power 4. So from this, we take out B minus A times C minus A common. Now remember that B is greater than A and C is also greater than A, so this will be positive. So what is left inside is C plus A times C square plus A square, and B plus A times B square plus A square, which will be greater than 0 for all A less than B less than C. So this entire expression is positive. Question 127 says that if A, B, C are distinct and A cube, A raised to power 4 minus 1, B cube, B raised to power 4 minus 1, C cube, C raised to power 4 minus 1 is equal to 0, then show that ABC times AB plus BC plus CA is equal to A plus B plus C. So we split the determinant into two parts. We split the third column. So we will have A cube, A raised to power 4, B cube, B raised to power 4, C cube, C raised to power 4, and minus A cube 1, B cube 1, C cube 1. So we take ABC common from first row here, B from second, and C from third. So we are left with ABC 1 A square A cube, 1 B square B cube, 1 C square C cube. And here we have the same determinant. Okay. Now you see there are 3 ones in both determinants. We perform R1 is equal to R1 minus R2 and R2 is equal to R2 minus R1, and then we expand. After expansion and evaluation, you can read this for yourself. It is too much to read. Okay. So you read this and verify that, and you will eventually end up with ABC times AB plus BC plus CA is equal to A plus B plus C. So go through this, and if there are any mistakes in this, let me know in the comments. Okay, and I will correct it. So, all right. Now, question 128 says that show that x1, x2, x3, where these are not equal to 0, x1 plus a1 b1, a1 b2, a1 b3, a2 b1, x2 plus a2 b2, a2 b3, a3 b1, a3 b2, x3 plus a3 b3 is equal to x1, x2, x3 times, there is a factor, I missed it. So 1 plus a1 b1 upon x plus a2 b2 upon x plus a3 b3 upon x. So here we have that. So we take b1, b2, b3 common from columns. b1, b2, b3 we take common, and then we multiply the rows with them. Okay. So we are left with x1 plus a1 b1, a1 b1, a1 b1. So we take b1 common here and multiply the rows. b2 common from here and then multiply the rows. So you will end up with this structure. Once we have this, we can take x1, x2, x3 common from rows. So it will be 1 plus a1 b1 upon x1, a1 b1 upon x1 plus a1 b1 upon x1, and so on. Once we have this structure, we can do R1 is equal to R1 plus R2 plus R3. And we'll be left with this. We take this common. This term in that parenthesis we take common, and then we will have 3 ones. Once we have 3 ones, we do C2 is equal to C2 minus C1, C3 is equal to C3 minus C1. You will have 2 zeros, and then you expand to get the answer. Question 129 says that show that 1 upon a plus x, 1 upon a plus y, 1 upon b plus x, 1 upon b plus y, 1 upon c plus x, 1 upon c plus y, 1 is equal to a minus b times b minus c times c minus a times x minus y upon a plus x times b plus x times c plus x times a plus y times b plus y times c plus y. So this question is similar to 90. So let's go to question 90. What was question 90? Okay, we'll see in a bit. I think I remember that problem. It's a big, complicated piece of determinant. Okay, 90. So this was the problem 90. Okay. So let's see this problem, what it is like 90. So let's revisit the determinant, what it is, 1 upon a plus x, 1 upon a plus y, and so on. Okay. So let's see problem 90. Okay. So here, this column is 1, 1, 1. That's the only difference. It is also 1 upon a plus x, 1 upon a plus y. And this third column is 1. All right. So let me see that again. 90, right? Okay. All right. So yeah, it is actually simpler than 90. So that's why I have left it as an exercise. So try solving this, and if you are unable to solve it, let me know and I'll give you the full solution. Try to solve it like 90. Question 130 asks us, show that the determinant a square bc ac plus c square, a square plus ab, b square ac AB B square plus BC C square is equal to 4A square B square C square. So what we do is we have this determinant. So we take A common from first column, B from second, and C from third. So we have ABC times AC A plus C, A plus B, B plus A, B plus C, C. So what we do here is we do R1 is equal to R1 minus R2 minus R3. So we are left with minus 2B, 2 minus 2A minus 2B 0, A plus B, B plus C, C. And once we have that, we expand, we get 4A square, B square, C square. So with this, we come to the end of question 130, and let me show you the website. So the website is astrologer.org, and you can download the PDF from second link and third and fourth for algebra, trigonometry, and trigonometry. The PDF won't have date, so you take this date and add it to the downloaded PDF. And I cannot put this date into the PDF itself because that will make all existing link invalid. Okay, and you can come between 30 days or something, and then you see if your downloaded PDF has this date or not, and if the date is this date is latest, then you can download it again and update the PDF. Okay, this HTML format will be gone. I don't want to keep HTML format. There are typographic issues which comes when you try to produce multiple formats. Okay, so the question answer website is the 8th link. All right, so you click it, you will come to mumika.astrologer.org, and you can make a login here and ask questions. So the tags which I have created for class 12 students is algebra, calculus, coordinate geometry. All the geometry is not in class 12 of India, probability, trigonometry, and a general tag mathematics. So come and join the community and ask and answer questions, and let's grow by learning from each other. Okay. So with this, I will end this video here, and I'll see you in the next one tomorrow with 10 more problems of determinants. So thanks a lot for watching the video. Keep learning, stay curious, and most importantly, enjoy.